Reflex, Components Made Easy, was presented as part of the Flash in the City conference. This presentation was originally recorded on June 12, 2011, in New York City.
All right, everybody, how's it going? Are you ready to rock? No. All right. So I'm going to be flying through this presentation. It's on Reflex components. So if you're not here for Reflex components, that's all right, but you're probably in the wrong spot. How many people here are Flex developers? Flex. All right, cool. How many Flash only? Flash AS3 stuff? Kind of, okay. All right. So Reflex is a set of components that are Flash only, but you can use them with Mxml. How many people have heard of Reflex before this? How many people have seen a presentation before on Reflex? All right, so a few. All right. I'm going to be flying. Okay, let's see. Introduction on me. My name's Ben Stucki. I normally wear a hat like that. You can check me out on Twitter. It's at Ben Stucki. I worked on a project like this before. I worked on a project like that before. They're cool. You should check them out. That one's called SpatialKey. I have an LLC called Digital Analog. We do flex consulting. We're booked, but you can talk to me about it if you like. Session outline for this part. What is Reflex? So this is kind of a flex versus reflex comparison. I got some good advice from Joel last year to not mention flex at all during my presentation, just talk about the cool parts of my component set. And I decided to go in the opposite direction and compare them directly a lot. So before I do that, I'm going to... Oh, I need power real fast. Before I do that, I need power. Hold on. All right, there we go. Saved. Okay, also, I'm going to hop into this other presentation. A lot of people ask me why build Reflex, and it has to do a lot with this. This is another presentation I give quite often on the art of computer science. I'm just going to do a quick section on it because I think it describes what I'm going for. Can you hear me on the mic? Hey, guys in the back. Shh. All right, that worked. Right, so good architecture, I think, isn't about being smart. It's about avoiding pain. A lot of it's simplicity. This is why good is better. It's not just less bugs and better performance and whatnot and high architecture. It's about technical debt. How many people have heard the term technical debt before? Awesome. So technical debt to me, it's basically just the CRUD that gets in your code that is hard to work with, but you had to put it in there real fast to make something work. Basically, it boils down to the fact that it's harder to write new features on top of bad code. And you have to go in and fix the bad code and pay back that debt before you can really do a lot of new stuff on top of it. These are some other people's visuals on technical debt. This is sort of speed at which you're developing the project is the vertical, and the horizontal is just time. This is your ideal timeline that you have planned for a project. Eventually, the speed at which you're actually accomplishing the project is kind of off target, but you're doing good code. So at the beginning, it's like you're doing things the right way, it's just not quite fast enough. At some point, there's pressure from the outside, management or clients or whatever the case is, and you just need to get stuff done, and you stop doing it the way you'd like to do it. It just needs to look like it works, and you try to find that release date. This area here in between where you're coding bad stuff is basically technical debt. The problem is if you don't take the time to pay back that debt and fix it, which normally you don't because there's a second release scheduled, then it affects your velocity and it starts being slower and slower at each iteration to develop on top of that older code base because you're dealing with a lot of that fast code, like unintentional code, I would say. So a lot of it is just avoid design death. That means like architecture design. Design death essentially means there's no intention behind the code anymore. It's just a mass of code. Feels basically like this. You know, there's no hope in the there's no system anymore. It's just like good luck. You know, it feels like this when you dig into it. Yeah, so it's fun. Bad coding philosophy, I think, I've heard this before. It's all right. There are 1,000 ways to code it, and all of them are right. But the problem with that is this is a way to code it. Actually, this probably passes a lot of unit tests. There are cases where this kind of code can pass all the unit tests, but you still have no idea how it works, and if you need to go in and change something, you're a little bit screwed. So my philosophy is there's probably one perfect ideal way to code it, like the unicorn way to code it, but you'll never really know how. That doesn't mean you shouldn't try to make it better, right? So good code. So here are a few rules that I use. This is basically why I started Reflex. I feel like there's a lot of technical debt in the Flex framework, and going in and trying to customize things in the framework, customize on top of components, extend components. You run into all kinds of technical debt that's there that's kind of unintentional. It just exists. So Reflex is kind of a fresh start, really trying to achieve a lot of the same goals. These are the rules that I subscribe to, and these are the rules that I use kind of going into the Reflex framework. Good code shouldn't make you feel smart. If you can make it simple, go for simple, right? It's not over-architected, hopefully. Simplicity through separation and singularity. I think these are two of the main issues we deal with in code. We want we want responsibilities to be separated out. So each kind of responsibility that happens is in an isolated place. But also you don't want duplicate code. So there's this process of separating items out where there's too many things in one class going on. But then you might create duplicate code separating those things out. So you figure out how to not have the duplicate code. So it's a bit of a process there. Right. So rules of thumb describe what your class does. How many times did you say and? That's where you need separation. You need to separate that out into two classes probably. I think a lot of problems are really simple at their core, like they're naturally simple, but humans have a way to, especially when they first encounter a problem, they like to overcomplicate it, and you really have to understand it before you can provide a good solution. So just try to understand the problem first before you go and solve it. That's what I think. Create systems, not code. So that's what we're doing. Cool. So let's jump back into this one. So applying that to Reflex, I'm going to go through, whoa, what happened there? Oh, all right. All right. Whoa. So these are, I think, not necessarily the features that are advertised in Flex, but these are the main systems that are involved in the Flex framework, the sort of underlying architecture. A declarative syntax, that's Mxml, state management, invalidation framework, styling, virtualization, binding, measurement and layout, deferred instantiation, collection binding, transitions. A lot of these have complex problems that are solved and addressed. We're basically trying to address those same problems in AS3 from scratch. So, right, so we're doing the same thing, Reflex framework. If you want to think of it in simpler terms, it's basically a set of AS3 components, kind of like minimal comps. You can just grab some. You can use them in Flash Pro, so they're AS3 only, but they have a little more extensibility to them, so there's skinning involved. We also focus really a lot on being lightweight, but you can just pull out a slider and throw it in Flash Pro and it'll work. So one thing that's a little different, actually you can use minimal comps technically in Mxml. Has anybody used minimal comps in Mxml? Oh, just me. Okay, well you can. Pretty much any Flash thing you can instantiate in Mxml. So this is kind of written, it's all AS3, the core framework, but it's written in a way that should make sense to use in Mxml. You can use binding, so it plays nice with binding. Mxml skinning, it's very similar to Flex 4. So let's look at a little bit of code maybe. So skinning. So, oh, by the way, if you want to go to reflex.io, or if you want to write it down and go to it later. Oh yeah, so two things. Reflex.io, you'll see a landing page there for a new project that I'm working on, and you should sign up, put your email in there. It's basically a wireframing type tool. That would be cool. Also at the bottom, there's a link to reflexplatform.org, I think. And that will give you a ton of information on Reflex. It links to our docs, links to the GitHub repository, links to our build server. You can download the latest SWIC, so there's lots of stuff there to check out. So, and it also has a link to these code examples. And if I can get my little window going, let's not close that. Let's pull this up. So these are some of the examples we're looking at today. This is all done in Reflex, so with Reflex stuff. Buttons and labels, I think we kind of skipped that in the Prezzo, but just an example of a few buttons. These are really simply skinned, but that's not to say you couldn't go in and provide a lot better skinning for them. There's some text input controls. Those are still early on. Sliders and steppers. So some of this stuff I think we might touch later. But here's skinning. This is the code for the example we're looking at. Or this is the example we're going to look at the code for. So it's just two buttons. One's the default here, and one's this custom skinned button, which is beautiful, right? So that's what we're looking at. So there's a container at the top. It's very similar to Flex stuff, except you notice it's in a different namespace. So it's in the Reflex namespace. So it's not using any Flex stuff. It's all non-Flex Mxml. Sorry if that might blow your mind a little bit, but there's no Flex stuff, but it still uses Mxml. Okay, so there's a container, and then there's just two buttons. Here's the default. This one has a skin assigned. It uses this example button skin. There we go. So, and it should look very familiar to Flex 4 stuff. There's a skin class we can use for that. There's some states. So it uses the same state syntax. We're basically taking advantage of the compiler expectations. So you can do color.over here. There's just a rectangle defined. And it's good to go. There's a label there, right? So this is a skin part, label display. It's meant in the Mxml workflow to feel a whole lot like Flex 4 stuff. So we don't have all of FXG quite yet, but we do have rectangle and some basic like rounded rectangle stuff going. There's also a few other workflows for skinning that I'm not touching on. All the default skins, if you look in the code, are AS3 only. So there's a AS3 workflow for skinning using the graphics API and with some states stuff. And there's also a Flash Pro workflow where you can just go in Flash Pro and draw some stuff with keyframes that are named the right thing, and it'll use that for the skin. So that's pretty handy. So states, yes, states, those states, the Flex 4 states. Also, you can use states in AS3 only. Check it out online. Layouts and measurement. This is another thing that's not done in AS3 components a lot that we're basically doing. So even if you use it in AS3, we have a layout and measurement system somewhat similar to Flex 4, including constraint and percent-based layout, so you can do 100% width, or you can do left 10, top 10, that stuff. And you can reassign layouts, so you can come up with custom layouts. It's all based on an interface. It's good to go. Right, so it's pay-as-you-go, Flash integration, we talked about that. Smaller size, so this is pretty good for, say, game development where you want to do a menu system. You don't want all the Flex size coming in. It's a good use case. It's really good for mobile, so we're focused on mobile early on. That's sort of what we're targeting. Radically customizable, so skinning is a big part of that, and also behaviors, which I'm going to touch on. And long-term, we'd like this to be one component set to rule them all. So it sort of exists on the AS3 side and in the Flash Pro workflow. So I think it's a good substitute for the Flash Pro components, and it exists in Mxml, so it's a good substitute for Flex stuff. And we're looking at making it easier to use inside of a Flex workflow later on. So let me know if you're interested in that. Mobile performance. Yeah, performance is something we're looking at too, because we get the chance to start over here. We get to do some pretty neat things to optimize for performance on mobile, like really flatten the display list, some items like that I think I'm going to talk about in a second. Yeah. So there's a few key differences in ours where we made a different decision than the Flex people did. I'm just checking my time real fast. I'm good. So these are a few of the kind of core geeky architecture differences. We have a content collection in all the container classes. So instead of overriding add child, which Flex does, and is a huge pain because then if you add child something that's not a UI component, you get a nice runtime error. Instead of doing that, we have content.addItem. So content is a collection. It's a collection of children that's part of the Reflex DOM. So if you want to go in and do crazy customization outside of our framework, outside of our DOM, you can still just do add child. We basically don't know it exists. We just, whatever you want to do with it, it's fine. Our DOM is under content. So if you do content.addItem, we're going to track that for layout, for measurement, for all the items that we're concerned with as part of our layout and measurement and validation system. We'll track it. If you just use addItem for any sprite or shape or anything, we basically don't know it's there, and you can do whatever you want. So that's very helpful on projects. We have multiple display base classes, so there's no really core UI component. We do have a component base class that's used a lot, but we have multiple bases. So for bitmap, we have a bitmap display base class. This basically helps us flatten the display list. So for bitmap specifically, normally if you had a UI component concept, that would be a display container, and then you'd have to add a bitmap to that as the bitmap to render something. So that's at least too deep already. And performance optimization for mobile, you want to shorten the display list as much as possible. So having multiple base classes here really helps us keep the display list as flat as possible. So for example, a checkbox component, the one that's included in the framework, this is the base class structure for it. So checkbox extends component, which extends display, which extends sprite, if you're interested. We also have an invalidation and lifecycle system. It's essentially a utility, and we worked very hard to keep this system out of the dependency chain for components. So it's something, right now it's fairly static, but it should be pluggable later on, whereas in Flex it's really built into the base class quite a good bit. So in our case, we're just removing that functionality. We want it to be reusable. Even if you have your own custom base classes, you can still use our system purely just by playing nice with the interfaces and use your own invalidation or your own layouts and measurement or anything really. So invalidation functionality is placed in a utility, and it's quite useful. We're also playing with a simpler workflow for letting developers access invalidation, which you have to do quite a lot in custom component development. How many people are familiar with commit properties in Flex? Yeah. So This is essentially a replacement workflow for commit properties. Instead of having to set up an invalidation flag or a dirty flag of some kind, and then set that in the setter, and then call invalidate properties, and then override commit properties, and check for the flag, and do your work for all these different things. In this case, you just put the invalidate metadata above the function that you want to call after invalidation or when a validation pass occurs. And as part of the properties, you define the properties in the class that cause this invalidation. So it basically gets rid of a lot of code. It's not that it does anything different behind the scenes, but it's just easier to develop with if you use this workflow. So something we're playing with. That's why it's got the star behind it. We're not sure long term if we'll go with it, but it's pretty nice. Separation of concerns is also an interesting difference between us. We have a number of VO type objects which are used for common data. Examples here are for scrolling and for selection. I'll show you a few of these in the framework itself. So this is where the magic happens, right here on this box, really. Yeah, so they're under the data package, and these are sort of where we took really common functionality between components and sort of put them in their own classes. So position, for example, is used. It basically is just a value that's between a range, more or less. So the range is here. So there's a minimum, maximum, and then a value that's between. Sometimes the range is by itself for some components, but most of the time you need the value. Sliders use these. Progress bars use these. What else? Steppers use these, like the up and down stepper. Knobs of any kind, like volume knobs. A number of components can use this concept, just a value between a range. And now all of those basically can share the same position object itself, the same reference to a position. And there's less binding that goes on when they share that reference. And that's essentially what's going on in the example here. All of these sliders and steppers. It's not that there's complex binding going on, they just share the same position reference. And this stepper, it probably should be rounded, but you get the idea. And also for scrolling, so you can bind to the scroll area, to the same position object, and that's basically what's going on there. Same thing for position, range, and selection. We're using the same concept, and we're also looking at it in a few other areas. So selection keeps up with both if a single item is selected or if multiple items are selected, and also the event dispatching that has to go on when an item is selected. So basically multiple lists, even in different areas of your application, could share the same selection. So there's not a lot of complex binding that goes on. As long as they share the same selection, those events are going to propagate. Any questions on that part? No? All right, good. Okay, another area for separation of concerns are behaviors that are used for common interaction functionality. Many people are familiar with the behaviors concept we use. All right, so they're under the behaviors package. Like I said, simplicity, I try to keep it pretty straightforward. There's an interface for behaviors if you want to make your own. The idea is basically that you could make your own for common functionality you have in applications. Essentially what happens is, let's see if this is in the slides somewhere. Yeah. So, before I dive into the code, I'll go through some of the slides. in Flex, they separate out the skin this way. So the component sort of still holds the data, still has a lot of the code and functionality around interaction and state management, and they separated out the skin for Flex 4, which is nice, really nice. We're taking that a little further. In our model, the component holds the data and is basically really stupid. In fact, if you look at one of the components, let's say like this is interesting. Say like the checkbox that we saw the structure of earlier. So it extends button. Really all this is going on. This is going to be injected later, but these are just default settings for the default button. Later on, we're going to have a better way to do that. Extends button. You can see button is also quite stupid. It has a label and selected property. And then it has its own sort of default settings there at the bottom. It's 48 lines. Most of that's property stuff there. And then component is where the base stuff happens. So extending component, basically you're not adding functionality quite yet. You're just adding the properties you want and the default settings you want, which is really nice. And then the functionality that you want to add is where behaviors come in. So really, even the core functionality is added by behaviors. You can have more than one assigned to a component. Their job is essentially to listen for events, both events coming from the component about its data, and also events from the component that are user interaction events like mouse click or touch events from the component. So they listen to those events and respond to it in some way by probably setting data on the component. And so the behaviors really only interact with the component, and then the component is bound to the skin. We don't use mediators, so no. Right. So yeah, what do we need mediators for? Yeah, we don't need mediators. All right. Yeah. Okay. Right. So the behaviors, when they're instantiated, they get an instance of the component. The component is essentially the data model, even though it probably does extend display, but it's treated like a data model object as far as the behavior is concerned. So, behavior extends event dispatcher. It's actually pretty light, and then you can extend behavior, or you can implement iBehavior. And in this case, select behavior is the one that's used to determine if an item is selected or not selected, or if a button is selected state or not selected. Right? Flash skinning, I talked about that for a minute. Okay, so let's take a look at, before I get too far down the rabbit hole there, selection. Just as an example of one of the behaviors. Sorry, that's the selection object. Let me get back to where I was. Do this. All right, so let's say select behavior. Here's an example of a simple behavior. So you can see this one, it extends behavior. You get some handy metadata shortcuts when you do that, but you could implement iBehavior if you want to. And what we're doing here is we're binding this property to the selected property of the target component. So that's what this custom metadata tag here is doing. So binding means whenever target.selected changes, it's going to change this property, and we can keep up with that internal to the behavior. This really helps make it unit testable, more or less. So each of these behaviors have isolated functionality. It's really easy to test. In a unit test, the dependencies are completely well. There aren't a lot of dependencies, so you can mock the objects and unit test them quite fast. And then we listen for events on what we're interested for. In this case, we're interested on the click event of the target, which is our component. And when there is a click event, we just toggle the selected property. In this case, we toggle our own selected property, and this binding tag is two-way binding, so it's going to send it back to the component. And then the skin might be listening for that property as well, so it will update the skin if it needs. Right? Does that make sense? Any questions around that? Cool. The component. The component is essentially the data model. Yeah. Yeah. So one example, good example for behaviors. This is normal scrolling. We've got these scroll bars. Actually, this is the vertical scroll bar, even though this is controlling vertical scrolling, even though it's horizontal. Technically, this could be a stepper or a progress bar, for that matter, or a knob. So you just reference the same position object that it's changing, and you can see here there's no interaction with the image itself. And we're going to take a look at that code real fast. Close some of these, close some of those. So let's see. Oh, no, that's in Behaviours, sorry. So let me find, I'm in a different project. Okay, scrolling. So here's the scrolling example. I've got scroll position objects up here instantiated just to keep them for safekeeping. And I've got the scroller here surrounding my bitmap image, which is a larger full-size image. I'm just binding it up to the horizontal and vertical positions objects. And I'm binding these scroll bars also. So the vertical scroll bar and the horizontal scroll bar are bound up to the right positions. Actually, I think this code might be a little updated, but that's essentially what's going on. So to show you an example of a custom behavior in use, we'll take a look at the behavior example. This is essentially the same thing with one modification. In this scroller, I've added a custom behavior. So this doesn't replace all the behaviors, but it adds this one to the list of behaviors that exist for that component. This one's a touch scroll behavior. It essentially listens to mouse events. It's assuming touch events get translated, and it'll let you throw the thing around. So this is that example. So you can still scroll this way, but with that custom behavior, you can interact with the image directly and give it a toss. And so nothing in the component or the skin or the other behaviors know that functionality exists, right? And essentially that touch, what's it called? Touch scroll behavior is also isolated. All it needs is a reference to the vertical and horizontal scroll positions and a reference to the component. It's listening to mouse events on that item, and when those mouse events occur, it's affecting the vertical and horizontal scroll positions. It really doesn't need to know anything else about the component. It's really easy to test, and it works out. And you can see, because it's hooked up to those positions, it's also affecting the scroll bars themselves. Just pretty nice. Any questions there? Everybody's falling asleep. Okay, so it includes a simplified graphics API, flash scanning, yep, that's good. Flattened display list we talked about. Oh yeah, interesting thing on this is that skin extends event dispatcher. So this is also to flatten the display list. We really would like it for components to just be one display object when possible. So obviously that doesn't always happen, but that's the ideal case, right? So for a button, we want that to be one display object container with maybe a text field in it, and keep it as flat as possible for mobile. And that's pretty much what happens in the button now, because skin extends the event dispatcher. It's probably got a rectangle in there for the coloring, for the background coloring that just goes to the graphics. And then it's got some sort of text item in there, which essentially extends a text field, which is also part of that multiple base classes. So there's just a text field in there, and it's good to go. Right? Pretty rad. Essentially what we do is when a component is assigned a skin, those the children of the skin are assigned to the content property of the component. So there's not a lot of binding or anything that happens, right? Yeah, it's pretty awesome. I think it's awesome. All right, it's awesome. I thought so. Now I have validation. Yay! Right, so event dispatcher skin, and then checkbox skin, for example. So trying to keep it limited, both in the extended classes and also in the display list, which are a little bit separate. Yeah, so these are some interesting differences too. All containers that we have, basically everything that has that content property that you can add item and add a child to it, have a templating system. So you can add display objects to them. That's awesome. But you could also add, say, a data object to it, and it has a concept of a template, which is essentially an item renderer, and it'll use that template to create a new display object for whatever data you passed in, and it'll put it on the display list. That basically works for all the default containers like group, vgroup, hgroup, whatever. Yeah, I didn't necessarily intend to do that, but it turned out to be less duplicate code to just put that templating system in the core container class than to make a whole different container class with a lot of duplicate code around what happens when you add a child, remove a child, and you have to do the invalidation stuff and the measurement junk. So, and it's pretty quick to put the template system in, because if you add a child and it's not a display object, you go, oh crap, you have to pass something to the template system to get a display object. No big deal, it's like one extra line. And it's referenced by interface, so if you don't assign it a template, there's no extra weight, right? It's part of pay-as-you-go too. Andy, what do you think of that? All right. Virtualized collections aren't done yet, but there's a system in place for them that's worked for me successfully before on projects. Almost out of time. That's cool. I'm almost done. Yeah, okay. I want to say soon, except I've said that before. So I am working right now full-time on a project that uses Reflex pretty intensely. I worked on it on projects before that were part-time, like a little consulting here and there. But now it's like I'm working on it on not just Reflex, but on a product that uses Reflex full-time. Collections will be involved. I'd say probably 3 months, I want to say, somewhere in there. Virtualized collections. So if you have a list, and say your list has 10,000 items, data items that you assign to the list, you don't want to create 10,000 item renderers because only 5 are going to show up at the same time. So virtualized collections is a method that lets you make sure you only create the item renderers that you need. In Flex's case, they put most of the virtualization logic responsibilities in the layouts, which means if you want to make a custom layout that supports virtualization, it's quite hard. For us, the virtualization responsibility is really shared between the collection. So we have a virtual collection, which kind of hides to the outside world a great majority of the data. And it is scrollable. So the collection is scrollable, and as you're scrolling, you're kind of removing and adding items to that collection. So to the component, it doesn't really know that exists. And then some of the responsibility for smooth scrolling is still inside the layout, because the layout doesn't want to jump when items get removed or added. So there's a little bit there. But it's it's a lot simpler than the Flex method. There's some outside cases it doesn't handle, like really large discrepancies between item renderer sizes, but I can deal with that. Any questions around that? Oh, okay. Style binding. Wow. What else do I have? All right. I want to maybe get back to style binding. Layout properties. Oh, this is the good stuff. Okay. So virtual containers is something we're working on. Basically, V group, H groups, and groups that aren't display objects. They just are responsible for layout and measurement. That'll be pretty handy. Layout properties are really, you should just ask me on the side about layout properties if you're interested. They're really cool. They're really cool. All right. Style binding. This will be the last thing, but a real big problem in Flex Force skinning is getting style properties to the skin the right way. Style binding basically will let you bind which styles affect, say, a fill object or a stroke object. So you can sort of go through this utility to consolidate multiple, say, border color, border width properties, or background fill kind of properties. Automatically consolidate those onto a fill object just by metadata in the skin. So it really, really simplifies making skins stylable. So if you're interested in both layout properties and style binding, talk to me. Okay, where do you sign up? Well, go there. Go there. That's mainly a landing page for the new product I'm working on. It switched recently, but you should definitely go there and put in your email. Quite interested in that, and I'll get you on the beta for the thing I'm working on. And also down at the bottom, there's a link to reflexplatform.org, I want to say, and that's got all the really just a lot of information on this framework. You can get to all the code. It's all open source. It's all MIT licensed, and it's got, you can look at the build server, you can look at the docs, you can go on the support forums. It's all there. Questions? Answers? Yeah. So Flex. So Flex altogether is upwards of 400K, but of course there's RSL loading, so it depends on how much custom stuff you're doing outside of the RSLs, but you're still probably somewhere in the 200K range for a Flex project. Our entire component set as it exists today is somewhere around 78K altogether. It's pay-as-you-go, so if you just use a button, that's, I think, somewhere around 26K. And then as you use more, it goes up to around 78K now. Yeah. Right. So it's on GitHub, so you can go and fork it and just start customizing it yourself. If you're planning on contributing back, feel free to give me an email and tell me what kind of work you're looking at doing. I really would love some contributions. So, but that's the best way, because if you're working on something that you want to get pulled back in, I'm sort of like the crossing guard for that. But for the most part, if you're looking to add something, I want contributions, so I'm likely to want to accept what you're making. And it's really easy for me to see what branches are going on in GitHub. So there's a chance, even if you don't, email me and you're making changes on your branch, I'm probably looking at them. And if you're putting in a lot of work and it's going in the direction I wasn't planning on going in, I'll probably give you a ping and just see what your use case is. But yeah, it's pretty fluid, and you have access to it basically the same way I do. You can start going in and make changes. Anything else? All right, thanks, guys. Thanks for hanging out so late.